Hello students, Chapter 1, Topic 1.8 Electric Field. What is electric field and how it works? To explain that, we take an illustrate of magnet and iron strip. Before starting and comparing them, I would like to tell you that electric field and magnetic field are not 100% equal. We are taking an example of magnet and iron strip to understand an imaginary concept of electric field. Please do not compare them at 100% point. Let's start. Take an Cartesian coordinate system x, y and z. At origin O, placed a q charge on it. Now from origin at a distance r, consider a point P which has charge small q. In xyz Cartesian coordinate system, put a capital Q charge on the origin. From origin to the P means at r distance, consider a point P have charge small q. Now the force between capital Q and small q is, according to Coulomb's law, is F is equals to 1 upon 4 pi epsilon 0 q by r square into r caret. R caret is the required to denote the direction of force between capital Q and small q. Now this equation is divided by small q. F by q 1 upon 4 pi epsilon 0 q by r square into r caret. Now what is F by q? F by q is force per unit put a iron strip. Iron strip is in the field of magnet. If we remove iron strip, there is no change of the field of magnet. But if we remove the magnet, the force will be 0 on the iron strip. So if we remove the magnet, we will get some result. But if we remove the iron strip, the magnetic field does not change. Similarly, here we have two charges, Q and a small q. Capital Q is quite larger than small q. Force between them is repulsive type. Force between them is repulsive type because both are positive. If we remove capital Q, the force on a small q will be 0. Small q will be 0. But if we remove small q, there is no change in the electric field of large charge capital Q. So electric field of the capital Q according to this equation is 1 upon 4 pi epsilon 0 q by r square into r caret. Here E is equals to F by Q. Therefore Q into E is equals to F. Take a scalar form. QE is equals to F. For unit charge, for unit charge, unit charge means take Q equals to 1. Electric field is equals to applied force. Electric field is equals to applied force. Electric field is just a field. It's just a field. It's an effect. Let's consider some point. First point. Here, capital Q is a source charge, means a charge which is responsible to create a field. Small q is tested charge. What is tested charge? Here, capital Q is a fixed. Now, we can change the position of small q according to our choice. At a different places, we will set a small q. Due to the different position, the force on small q by capital Q will be different. This clearly seen that the electric field will be different at different point. So capital Q is a fixed, is a source charge, and small q is a tested. By using it, we can test a field of capital Q. Now, F is equals to 1/1 4 pi epsilon 0 q by r square. 1/1 4 pi epsilon naught q by r square. This clearly seen that F is proportional to Q. Therefore, F divided by Q is equals to constant. But F divided by Q is what? Electric field. So electric field for a particular distance is constant. Now, the ratio of F by Q is very small. Why? So listen. By the tested charge, we know that capital Q and small q both are positive, both repel with each other. Due to the capital Q, a small q can be displaced from its position by the repulsion. See, due to capital Q, small q can be displaced from its position due to repulsion. But due to small q, capital Q cannot change its position. Due to small q, capital Q cannot change its position. So for that, F by Q should be very small. Electric field E is proportional to 1/r square. How? See, capital Q is constant, 1/4 pi epsilon constant, E proportional to 1/r. As R increase, E decrease. As R decrease, E increase. Means electric field near to the charge, electric field near to charge is maximum. Is maximum. Now, let's second direction. Positive charge. Direction is radically outward. Radically outward. And for a negative charge, it is radically sorry, inward. For a negative charge, it is radically inward. Direction of positive is outward, negative is inward. So direction of electric field from positive charge to the negative charge. This field emerge from the positive and entering to the negative. So direction is from positive to negative. If the two charges are given positive and negative, the resultant direction field is from positive to the negative. So in a nutshell, electric field depends upon capital Q, the value of charge, and a distance to where electric field is found. Electric field is depends only two things. One is capital Q, other is a distance. It does not depends upon the force and a small q. This is a electric field. Electric field is a topic of an electric field due to a charge, and now we will discuss electric field due to system of charges. For this we will consider four charges. Here it's charge and its electric field. Another charge, its electric field. Remember, all the charges are positive. Here another charge and its electric field, and one more charge and its electric field. Now let's start and give the name. Any arbitrary name, Q1, Q2, Q3, Q4, from any reference point. The distance is R1P, R2P, R3P, and R4P. These are the position vectors, and this is a point P. Electric field due to Q1 is E1. Electric field due to Q2, it's E2. Due to E3, Q3 is E3. Due to Q4, it is E4. To understand the direction of the resultant electric field, we will use parallelogram method. Parallelogram method, chapter number 4, standard 11. Consider a parallel of E2 with E1. Why? Because to find out, or by using the parallelogram, we require head of one is on tail of others. This is E2. And this is a resultant direction of E1 and E2, which is E dash. Now find out E3. Take resultant vector E dash and its parallel. This is E dash. Head of E3 is on the tail of E dash. So this is a resultant vector. And the name is E double dash. Now E1, E2 and E3 are completed. So take E4. Take again parallel of E double dash. Parallel of E double dash. Start from the head of E4. Start from the head of E4. So this is the electric field direction, resultant electric field direction is here, E. So resultant electric field direction of Q1, Q2, Q3 and Q4 is in slightly upward direction. Let's start some equations. Electric field, resultant electric field is E, is a vector sum of E1, E2, E3 and E4. If n charges are given, so electric field due to n charges is E1 plus E2 plus En. Now let's start. The equation of E1 is 1/4 pi epsilon 0 capital Q R1p square R1p caret plus 1/4 pi epsilon 0 Q2 R2p square R2p caret, sorry, Q1 plus dot 1/4 pi epsilon 0 Q1 Rnp square Rnp caret. Now write down 1/4 pi epsilon 0 is common from all terms. Take sigma. Start from the sigma is 1, 2, 3, 4 to the n. Symbol is I. It's Qi upon Rip square Rip caret. So this is a electric field, resultant electric field equation for the n charges, and this topic is the electric field due to system of charges. Thank you for watching my video.